Hello and welcome to the first in a series of short webinars on model-based systems engineering for automotive applications. Today you will learn how the Dassault Systèmes 3DEXPERIENCE platform transforms all aspects of developing complex automotive systems, from defining and developing the architecture through to their implementation and validation in the context of a 3D virtual product. The platform delivers an integrated model-based systems engineering environment to imagine, engineer, and experience high-fidelity digital replicas that accurately predict a product or system's behavior through 3D experience, just like in real life. But why do we want to put 3D experience at the heart of the systems development process? Because 80% of today's vehicle innovations come from embedded systems. These systems account for 20 to 40% of vehicle development costs, and they are delivered as 7,000 technical and customer orderable functions that are defined by more than 300,000 requirements. The massive number of possible vehicle configurations makes it impossible to fully analyze the interaction of any one system with other systems within a real vehicle. For more than 60% of the development time, no real prototypes exist. And even when they do exist, they are costly to produce, often incorrectly defined, and are utilized in a suboptimal way. Less than 10% of systems engineers get validation time with these prototypes, resulting in the late discovery of system errors that should have been identified at the concept design stage. Typical automotive manufacturers and their Tier 1 suppliers use hundreds of disconnected systems engineering tools to implement these functions and systems. And in doing so, they create many thousands of models of the systems being developed, with each tool having its own view or model of the system. But these individual models are largely disconnected from each other, as they are authored and managed by different legacy and proprietary tools. This limits cross-discipline collaboration and integration, making it difficult to build complete and consistent system views that integrate multiple engineering disciplines. It makes it extremely complex and costly to model and simulate the behavior of systems in the context of a complete vehicle, and also impossible to easily reuse system assets across multiple vehicle options and programs. The business impact of these issues is increasingly serious. Programs are delayed, products are poorly integrated with suboptimal systems, and design and engineering costs are inflated by unsynchronized and duplicated development effort. And it is getting worse. As product complexity and demands for variance increases, it becomes more difficult to master and optimize the development effort, often resulting in duplicated data that becomes difficult to manage across all programs, options, and variants. What's needed to address these challenges is an integrated model-based systems engineering environment that drives the creation and management of digital replicas of existing or future systems to accurately capture or predict their behavior, just like in real life. We create these 3D experiences by using an open development environment that brings all engineering disciplines together to collaborate, define, and share a common and consistent systems definition. A definition which we use to model and simulate the behaviors of systems in the context of the complete product and its environment, just like in real life, and reuse systems assets across multiple vehicle programs and model variants. Dassault Systèmes addresses these challenges with a collaborative and open 3D experience platform for model-based systems engineering. This platform enables users to design and experience products and systems through a continuous engineering development process. Let's explore what we mean by 3D experience in the context of systems engineering. We provide an end-to-end solution with digital continuity to design complex products and systems, starting from their planned usage through to design and implementation, and optimize, verify, and validate these systems through virtual simulation at the conceptual design stage, reducing the need for physical prototypes. This 3D experience platform is an open environment that can be used in conjunction with your existing tools and adapted to suit your processes. It comprises a set of integrated applications that cover systems architecture and requirements, to define and compose the system by considering multiple viewpoints through a set of integrated requirements and architectural models. Embedded systems architecture, to define, manage, and implement complete embedded architectures with electronic and electrical components and their interfaces. Embedded software, a rich tool set for developing AUTOSAR-compliant embedded systems. Mechatronic systems behavior modeling using open standards, Modelica, and functional mockup interfaces, or FMI, where we simulate the system definition to predict and validate upfront the system behavior, just like in real life. And electrical systems, to provide the electrical interconnect between the many ECUs, sensors, and actuators within the vehicle. We manage the creation and lifecycle of all of these systems assets through a rich collaborative framework that supports the creation, sharing, and reuse of information. The 3DEXPERIENCE platform accelerates time to value by delivering powerful cross-discipline collaboration capabilities that span all stages of the system's definition, design, simulation, and validation process. Through powerful services for social collaboration, dashboarding, visualization, and content management, it provides a scalable solution capable of supporting systems development from the smallest to the largest and most complex engineering projects. Program and lifecycle management with configuration and change management of all assets and management of product lines, and use powerful tools to manage and document compliance with standards such as ISO 26262. It integrates program and earned value management directly within the system's design environment, with task status collection and budget allocation and usage becoming a natural part of the design process itself. By collecting information passively throughout the design process, it provides decision makers with real-time assessments and gives increased confidence in information. The platform provides full traceability of information relationships across all models with a unified change and configuration management process that enables early visibility of the impact of changes to all data consumers, including across the supply chain, all in the context of a configured systems definition. Designing systems in a configured context means that we design the master system and all of its variants simultaneously. We develop a single standardized platform for all product lines with functional and physical variants based on customer and market needs. By reducing the number of explicit system definitions, we reduce the number of definition assets, the duplication and number of tests, and increase systems asset reuse across multiple vehicle options and programs. The 3DEXPERIENCE platform also helps you manage and demonstrate compliance with systems requirements and standards such as ISO 26262. Using powerful dashboarding, traceability, and analysis capabilities across more than 60 systems engineering tools, it is possible to assess the completeness of requirements coverage and impact of system changes across all engineering data at both the project and program level. What sets this solution apart is the fact that all applications within the 3DEXPERIENCE platform share an open, extendable, and common data model and repository to deliver a consistent view of information across all engineering disciplines and applications. The platform supports multiple open standards, including the Codex of PLM Openness, an initiative for establishing openness of IT systems in the context of PLM between customers, tool vendors, and service providers. Modelica, a standard, open, and object-oriented language for modeling and simulation of multi-domain physical systems. Functional Mockup Interface, a tool-independent standard to support both model exchange and co-simulation of dynamic systems models. AUTOSAR, an open and standardized automotive software architecture that enables the development and reuse of automotive software components. And finally, OSLC, Open Service for Lifecycle Collaboration, an open community that defines a set of specifications that enable integration of PLM, ALM, and IT software. The platform is built on an open and extendable common data model and repository that provides a single source of truth to ensure that all stakeholders always work with the same system's definition, design, and simulation data. It protects your existing investment in tools and processes through standards-based integration and sharing of information across common systems engineering tools. In addition, it enables you to quickly and easily get real business intelligence from the huge volume of distributed and fragmented systems information through powerful big data monitoring, federation, and analytic capabilities accessed through rich user-definable dashboards. So to summarize, the Dassault Systèmes solution delivers an innovative, open, and powerful model-based systems engineering development platform. It integrates all engineering disciplines through the definition of multiple system views in a continuous engineering environment that can be adapted to your specific systems engineering methodologies. An environment that can manage and analyze large amounts of data and enable the translation of this data into innovative systems designs through collaboration with partners and suppliers. An open platform that accelerates the development and validation of systems through rich 3D experiences, which transform the way organizations define, model, simulate, and validate complex automotive systems.
That brings us to the end of this short webinar. We thank you for your time today and look forward to working with you.